Assalamualaikum and hi everyone. We are going to discuss a tutorial question on sketching titration curve. So we will discuss question A. Sketch and interpret the curve of pH against volume of base for titration between 25 milliliter of 0.1 molar HBr and 0.2 molar NH3. So first we need to identify the analyte for this acid-base titration. What is our analyte? Since we are given with the concentration and volume of HBr, so the analyte for this reaction is HBr. Before you can sketch the titration curve, you need to identify 4 important points. The first one is the initial pH. The initial pH means the pH of the solution in the conical flask before the addition of base, before the addition of titrant. In this case, the titrant is base, which is NH3, ammonia. So HBr is a strong acid, so it will completely dissociate. So the concentration of HBr is equal to the concentration of H+, which is 0.1 molar. So we just substitute the concentration of H+ in the formula of pH, and we get the pH equals 1.0. When we start adding the NH3 into the conical flask, the pH of the solution will gradually increase. Okay, so for the first step is done. We have identified the initial pH. The second step is to identify the sharp increase. So we have 3 different sharp increase values that you need to memorize. The first one is between the reaction between strong acid, strong base, which is 3 to 11. Okay, reaction between strong acid, weak base is 3 to 7. And the reaction between strong base and weak acid is 7 to 11. For this reaction, this is the reaction between strong acid and weak base. So the sharp increase is 3 to 7. So sharp increase is the straight line that we are going to draw on equivalence volume. The third step is to find the equivalent point, or the equivalent pH and equivalent volume. So at equivalent point, the number of mole of acid and base react is equal. That means all acid and base are completely consumed, and we only have salt in the conical flask. So the pH of the solution in the conical flask at equivalent point is determined by the pH of salt, which is NH4Br. So we need to identify whether the NH4Br is acidic, basic, or neutral salt. Okay, write the dissociation of salt to produce positive ion and negative ion, and identify which ion comes from weak acid or weak base. So NH4 plus comes from NH3, which is weak base, and Br minus comes from HBr, which is strong acid. So in this case, only NH4 plus ion will undergo reaction with water. When NH4 plus react with water, it will produce H3O plus ion. So since the product of hydrolysis is H3O plus, therefore NH4Br is acidic salt and the pH is less than 7. So we have identified that the pH at equivalence is less than 7. Next, we need to identify the volume at equivalence. So we use formula MAVA over MBVB equal to the ratio acid to base 1 to 1. Just substitute the values and we get the volume of base at equivalent point equals 12.5 milliliter. Okay, step 4 is to find the final pH, which is the pH of titrant, the solution in the burette. So since NH3 is a weak base, so use ICE table to find the concentration of OH minus ion. So we need to find X as the concentration of OH minus ion. So use Kb expression, substitute the value of Kb and find X value. So here we can use assumption because the Kb value is very small, 1.8 exponent negative 5. So we get X value, which is the concentration of OH minus equals 1.8 times 10 to the power of negative 3 molar. Then calculate the pOH value and calculate the pH of NH3. Okay, we get the pH of base NH3 11.3. So we are going to use all these points to sketch the titration curve. Okay, we are going to use the pH, the initial pH, the sharp increase, the pH at equivalence, the volume of base at equivalence, and the final pH. Okay, to sketch the titration curve, so we start with drawing the y-axis and x-axis. The y-axis is pH and the x-axis is volume of NH3 added in milliliter. Okay, put the initial pH first, 1, and the sharp increase is from 3 to 7, and the final pH is 11. So draw the dotted line for the final pH so that your titration curve will not touch the final pH. And then put the volume at equivalent, which is 25. Sorry, the volume at equivalence is 12.5 milliliter. Since the pH at equivalence is less than 7, so we can put the pH when a 12.5 milliliter of sodium of NH3 is added somewhere below pH 7, okay, in between the sharp increase, which is 3 to 7. Then draw the straight line from 3 to 7, pH 3 to 7 for the sharp increase. Then you can draw the S-shaped curve. It will approaching the final pH. Label the equivalent point and the sharp increase 3 to 7. So in your titration curve, make sure you have the initial pH, the final pH, the equivalent point, the volume at equivalence, and the sharp increase, and please label all the values. Okay, that's all. Thank you.